Hello dear students, welcome to DAV Moyle Public School. I hope you are doing great with the chapter of sound. This is the second video of this chapter. Previously we have studied about sound, how are they produced, how are they propagated. In this even we have even studied about waves, the different types of wave, transverse wave, longitudinal wave. In this wave, in this video we will be studying about characteristics of wave. So let's begin. Now, in previous videos, we have studied about there are two types of waves. One is mechanical wave and the other one is non-mechanical wave. Mechanical waves are those which requires medium to travel from one place to another, whereas non-mechanical waves are those which does not require any medium. So based on that concept, we have characterized wave into two parts, transverse wave and longitudinal wave. We have discussed what are transverse and longitudinal wave in previous videos. So based on that concept, we will be studying about characteristics of wave. So there are certain characteristics of wave which are associated. So let's see. Now first one is phase. There are certain parameters to understand a wave like phase, amplitude, frequency, wave velocity and time period. So the first thing, that is phase. Now what exactly do you mean by phase? As you can see in this picture, a wave is there. So based on this wave, where are phase point located? So let us see. We have seen that in previous case, wave is a complete portion. As you can see, this middle line is the mean position of a wave. Mean position means the exact center of that wave, particular wave. That is the mean center of a wave. Now, if this is the mean center of the wave, what is second question arises, what do you mean by phase? So if you analyze this picture properly, you will find certain things common. So what are the things common? Let us see. So all points in a wave which are in the same state of vibration are said to be in phase. What do I mean by this statement? If I analyze this picture properly, there are certain points indicated over here with certain alphabets A, B and C. And if I understand this properly, if I consider a particle which is residing at point A, and if I analyze the position of the particle is moving in upward direction at point A. And as the particle is moving in upward direction, at point B it is coming in downward direction, and at point C it is again moving in downward. At point D it is trying to move in upward direction. At E again upward, and the sequence follows. And if you analyze this picture properly, if you see at point A, E and I, all particles are moving in upward direction. So one phase, that is A, E and I, is the first phase. Similarly, if I analyze at point B, F and J, all particles are moving in downward direction. As you can see, this at point B, F and J, particles are trying to move in downward direction. So motion of a particle at point B, F and J are in downward direction. So that is the second phase. Similarly, at point C, J and K, this C, J and K, particle is moving again in downward direction. As you can see at point C, J and K, all particles are moving in downward direction. So another phase, last phase, that is DJ. This D point, at this D position and H position, particle is trying to move in upward direction. So I have another phase. So what exactly do you mean by phase? All point in a wave are in same state of vibration, that is a phase point. The another characteristics of a wave, that is amplitude. Now what exactly amplitude means? If I again consider a wave which looks like this, so and this middle line, it is the mean position of that wave. Now the maximum displacement of a particle of a medium from its mean position, if I consider this as a mean position, now if the particle is the distance from the mean position to the upward position over here in vertical manner, that is the amplitude. It is denoted by A. As we have seen, this portion is known as, if you are talking about longitudinal wave, this upper portion is known as compression, whereas the downward is known as rarefaction. And if we consider wave in terms of transverse wave, then the upper portion would be called as crest. Similarly, downward will be called as trough, So the displacement from the mean position to extreme crest or compression part, that is the amplitude. As you can see, this line is indicated over here. So displacement from mean position to extreme top position, that is the amplitude. It is denoted by A, and SI unit, that is standard unit, it is meter. It is always meter. If we talk about CGS unit, it would be centimeter. Now, another characteristics of wave, that is frequency. Frequency is nothing but number of wave which is produced in 1 second. That is frequency. Oops. Now, what do you mean by frequency? Frequency, it is nothing but number of wave which are produced in 1 second. That is frequency. Or you can even say the rate at which number of waves are produced by a source is known as frequency. It is usually denoted by a symbol V, and it is pronounced as nu, nu, or we can even say frequency as small f. So it is either V, a sort of V, which is pronounced as nu, or frequency. And if you analyze this picture properly, a one complete wave is there. So what exactly frequency means? If one complete wave means, as you can see, this is the origin position and the particles which is going in upward direction and completed one cycle of it. So this complete thing is considered as one wave. This is not the one, this portion is not wave. The complete portion from mean position, origin position till extreme last position over here, that is one complete wave. Now what exactly do you mean by frequency? It is number of waves generated in 1 second, that is frequency. It is denoted by nu or f. The SI unit of frequency, it is hertz, which is written as HZZ. Now the next characteristics of wave, that is wavelength. As you can see, the word itself speaks the meaning in it, wavelength. So the length of a wave is known as wavelength. So in another word, we can even say the distance between two nearest point which are in the same phase or on a wave is called a wavelength. As you can see in this picture, one waves are there. The upper portion, that is compression, one compression. So if you analyze this picture, zero position, the particle is trying to go in upward direction, then it is moving in downward direction, then again over here. So one complete wave have been generated. Another wave which is starting from this position, it is going up and again going down. So I have two compression, as you can see, two portion is arising over here. So this portion is nothing but compression, or in terms of transverse wave we call it as crest. So distance between two crest is known as wavelength, or distance between two trough. This downward portion is known as trough. So distance between two trough or distance between two crest in terms of transverse wave, we call it as wavelength, or in terms of longitudinal wave, distance between two compression and two rarefaction is known as wavelength. It is denoted by a Greek symbol which is known as lambda. And if I analyze this picture properly, the distance from this crest till this crest, this complete distance is known as wavelength. It is denoted by lambda. And if I consider half of it, then it is obvious that it would be lambda by 2. Half if the distance is lambda, then half of lambda would be half by 2. So this portion would be lambda by 2. We will analyze this picture and concept of wavelength when we see some numericals and all more profoundly. I hope you have understood the concept of wave, characteristics associated with it. Thank you and have a nice day.